So we are going to be working with something called the quadratic formula today. We already have two methods for solving quadratic equations. One is factoring, and one is solving using square roots. Where the quadratic formula comes into play is if the coefficient of the x squared term isn't 1, and there's an x squared and an x term, and the coefficient isn't 1, and it's also not something that's a common factor that I can factor out of everything, I don't want to solve the thing by factoring. I want to use the quadratic equation instead. So the quadratic formula, instead. There are also some problems that are not factorable, and we're going to see some of those today. And something that's not factorable I could still solve using the quadratic formula. There are parts of the quadratic formula that are just always going to be what they are. Now on the board in the classroom I went through and derived the quadratic formula to show you how this equation can be rearranged to become this equation. That looks kind of weird, but it really does work. The things that will always stay the same, that will never change as you substitute into this, is the x equals the big long fraction bar, the plus or minus part, this big square root symbol. You're going to be squaring something, minus 4 times a couple of other things, and then this 2 on the bottom. Those are just part of the formula. They are always going to be in every problem that you do with the quadratic formula. What does change is the a, b, and c in those values. Where we get those is when we rearrange a quadratic equation to be in this form, where the x squared term, the constant term, and the x term are all on one side of the equation and it just equals 0, the coefficient of the x squared term, not the x squared term itself, the coefficient of the x squared term is a. And that will always be substituted into these two places where a is found in the formula. The coefficient of the x term is b, and that will always go, and I'm going to talk about this opposite thing here in a minute, into these two places for b in the formula. And last but not least, the constant is always c, and it will always be substituted for c in this formula. So when I look at this equation, the thing that I notice, and also on your test, you will be given the quadratic equation itself. You do not need to memorize this, but I will not tell you this part. You need to know what a, b, and c are and how to find them on your own. So, what I do notice about this first, though, is that everything's on one side of the equation and it equals 0. That's not the case in this equation. So to get rid of this negative 2, I would have to add 2 to that side. It's a constant, so I can't add it to the x term, and I can't add it to the x squared term, so I'm just going to add it out here at the front, because there's nothing, like term I can line it up with. And I get 2 minus 4x squared plus x equals 0. Now here it says a is not just the first term I see, a is the coefficient of x squared. So in this one, a is negative 4. b is the coefficient of x, which is positive 1. And c is the constant, which is that positive 2. Once I find the a, b, and c, now I substitute into the quadratic formula. So x equals, put your big long fraction bar down first, because this fraction bar goes through that whole side of the equation. And I look back up at the formula. All year I have said I will never, ever, ever read this as negative x, and I never have. It's the opposite of x. You can think of it as a negative 1 times x if you want to, but it is not a negative x. And at the beginning of the year, when I first said that, I put the quadratic formula on the board, and people went, ugh, because it looks kind of weird. And I said, the reason I will never read this as negative x is because you get to this and you think you have to write a negative number down all the time, and you don't. It's the opposite of x. So this is the opposite of b, or negative 1 times b. In this case, b is positive 1. So I do write negative 1 down there because it's the opposite of positive 1. Plus or minus, square root of, and it is just to take b and square it. In this step, only substitute. Do not calculate anything. And when we did notes in class over this, I said that at least 5 times in every class period. Do not do anything but substitute in this step. The only thing you kind of do is the opposite of b. When I write it in as negative 1. And then this says to take minus 4 times a times c, so minus 4 times a, which is negative 4, times c, which is 2. All over, it says 2 times a, so 2 times negative 4, since a equals negative 4. Now, the only thing I want you to do in the next step is this. We're going to leave the negative 1 and the plus minus. We're going to leave the square root symbol. We are going to clean up the denominator and take 2 times negative 4, and we're going to clean up what's underneath the radical by doing 1 squared minus 4 times negative 4 times 2. Well, 1 squared minus 4 times negative 4 times 2, don't hit enter anywhere in there, is 33. And then 2 times negative 4 is negative 8. At this point, just like you did when you were solving using square roots, you should expect to get 2 solutions to this problem. And the 2 solutions, just like they did with square roots, one's going to come from this plus in front of the square root symbol, one's going to come from the minus. So I write 2 different equations. One is x equals negative 1 minus the square root of 33 all over negative 8. And the other one is x equals negative 1 plus the square root of 33 all over negative 8. At this point, put this in your calculator, and you have to be careful. When you do this, you need to put negative 1 minus the square root of 33 and hit equals before you divide by negative 8. So this case, the x is approximately equal to, which is why I'm doing that squiggly equals, 0.84. Oops, sorry about that, 0.84. And when I do this one, x equals negative 1 plus the square root of 33 over 2. Remember, it's negative 1 plus the square root of 33 equals, sorry, not over 2, and then divided by negative 8 equals, and I get that x is approximately equal to negative 0.59. So what do I know about this parabola? If I were to graph the parabola y equals negative 4x squared plus 1x plus 2, it crosses, it opens down because the x squared is negative, although I could have moved everything to the other side, so this is a little bit more nebulous. But what I do know is it crosses the x-axis at 0.84 and at negative 0.59. And I said round the answers to the nearest hundredth where necessary. It didn't come out to be an even value, an integer of any kind, so I just put them in, rounded to the nearest hundredth. This one is one that looks like it could be factored because the leading coefficient of the x squared is positive 1. But if it turns out that you run through all the combinations that you can get to get positive 7 when you multiply 2 numbers together, it's only 7 times 1 or negative 1 times negative 7, because 7 is a prime number. And none of those combinations will add to positive 2. So I would also use the quadratic formula on this one. This is already with everything on one side of the equation and the zeros on the other side. So a is 1, b is 2, and c is 7. So x equals big long fraction bar, the opposite of b, so the opposite of positive 2 is negative 2, plus or minus the square root of b squared, so 2 squared, again, don't calculate that, minus 4 times a, it says, which is 1, times c, which is 7, all over 2 times a, which is 1. Again, at this point, we're going to simplify just these 2 pieces, and only those 2 pieces. So x equals negative 2 plus or minus, this becomes the square root of negative 24, and then all over 2. If you try to take the square root of negative 24 in your calculator, it's going to give you an error. It may say syntax error, domain error, but some kind of error. If you think about it, a square root undoes a square. So when you're taking the square root, you're basically saying what number or numbers, what number could I multiply by itself to get an answer of negative 24? Well, there isn't anything in the real number system that we're working with right now that will do that, because a positive times itself is a positive, a negative times itself is also a positive. I could never get an answer of negative 24. So I'm going to write no solution. There's no point in me even trying to calculate this because I can't. And technically, it's no real solution because when you're in advanced algebra, you will deal with another number system that will actually allow you to do this, but nothing that we're dealing with now. And as a quick look, if I graphed the parabola y equals x squared plus 2x plus 7, it ends up having a vertex at -1, +6, and it opens up. So there's no solution because the solutions are the x-intercepts, where this touches the x-axis, and it never does. So graphically, it's no solution because it never touches the x-axis. Algebraically, it's no solution because you can't take the square root of a negative number. In this last one, I need to identify a, b, and c, but the first thing I need to do is to get this x squared and this 5 on the other side. I can see this video is getting to be too long, so this will become part 1 of the notes. If you are taking these notes, you also need to watch part 2 and do this example and the part that I'm going to do at the end.